Welcome to this lesson on inequalities. Please make sure you have these notes in front of you so we can begin our lesson. My students, let's make sure we update our table of contents. The learning objective for this lesson says I can identify multiple solutions to an inequality on a number line. The vocabulary word for this lesson is called inequality. And unlike equations, inequalities have more than one solution. So the definition of an inequality is a number sentence that compares two quantities. The less than symbol, the greater than symbol, the less than or equal to symbol, or the greater than or equal to symbols represent the different types of inequalities. An example of an inequality would be 6 is greater than 5. Or another example of an inequality would be 6 plus x is less than 15. Both of these inequalities are comparing two different quantities. An example of an equation would be 6x is equal to 18. This is not an inequality because it has an equal sign. So for the key concepts, let's talk about the different symbols. The first symbol is the less than symbol. And some keywords that mean less than are fewer than and below. On a number line, the graph for this inequality will have a open circle, and it's going to point in the same direction as the arrow of the inequality. So it's going to point to the left because every single number on the left-hand side of that circle is less than. The next symbol is the greater than symbol. And the key words that mean greater than are more than and above. On a number line, the graph for the greater than symbol will have an open circle, but you're going to shade in the direction of the right because that's the same direction that the greater than symbol is pointing to, and all the numbers to the right of that circle mean those are greater numbers. The next symbol is the less than or equal to symbol. And some key words that mean less than or equal to are at most and no more than. On a graph, the less than or equal to symbol will be a solid circle, and you're going to shade everything to the left of that solid circle because all the numbers to the left of that is less than. The equal to sign means the solid circle. The last symbol that we have is the greater than or equal to sign. And other words that mean greater than or equal to are at least and no less than. On a number line, the graph for the greater than or equal to sign is a solid circle, and you're going to shade every number to the right of that solid circle because every number to the right of that is greater than. It's a solid circle because the equal to sign means solid circle. Another important thing that you want to remember is that the variables should always come first. So let's use these key concepts to discuss the following examples. So for example 1, they say graph the solution of the inequality. So I've got two different inequalities here, so let's graph the solution of the first one on the left-hand side. It says j is greater than 12. Notice that j, or the variable, is first. So we know that the problem is written correctly. So I'm going to go ahead and graph all the solutions. I'm going to place 0 on the number line, and I'm going to graph 12 on the right-hand side of 0. If you remember from the key concepts, the greater than sign has an open circle, and I'm going to place an arrow to the right of positive 12. What this means is that every number to the right of positive 12 is a possible solution. So basically any number to the right of 12 would work. So if you look at the graph, I have an open circle here. The reason why the graph has an open circle is because 12 is not part of the solution. So here's the reason why. If I go back to the inequality and I plug in 12 for j, 12 is not greater than 12. That is a false statement. So the reason why 12 has an open circle is because it is not part of the solution. But if we pick any number to the right of that, like 13, let's plug in 13 into the inequality. 13 is greater than 12. That's a true statement. So let's take a look at the inequality at the right. Notice j is greater than or equal to 12. J is the variable that comes first. So I know that the problem is written correctly, so let's go ahead and graph. On the number line, let's start with 0. And 12, it's going to be on the right-hand side of 0. So I'm going to place 12 here. The only difference is now I'm going to put a solid circle on 12 because this symbol says greater than or equal to. And remember, the equal to sign tells me to shade the circle in fully. The next thing I'm going to do is I'm going to draw an arrow in the same direction of the greater than symbol. What this means is that every single number to the right of 12, including 12, is a solution. So let's take 12 and plug it in. 12 is greater than or equal to 12. Well, that's a true statement. Let's take any number to the right of 12, like 13. 13 is greater than 12. That's a true statement. So anything on 12 or to the right of it would make this a true statement. So pause the video, complete the got it problems, and we'll discuss the answer in class tomorrow. Notice I have two got it problems on this slide. Got it problem A and got it problem B. And be sure to show me a graph for both inequalities. So for example 2, it says graph the solutions of the inequality. If we take a look at the example on the left, D is less than 4. We see that the variable is first, so we know that this is written correctly. So let's go ahead and graph. On our number line, let's start off with 0. And 4 is going to go to the right of 0. I'm going to go ahead and place an open circle above 4 because this is a inequality that just says less than. Now I'm going to draw an arrow, everything to the left of 4. Once again, I have an open circle because 4 does not fit the solution. If I plug in 4 into the inequality, 4 is not less than 4. That's a false statement. But if I plug in any number to the left of 4, like 3, so 3 is less than 4, that is a true statement. So this has an open circle because 4 is not part of the solution. It doesn't work. It doesn't make it true. And neither do any of the numbers to the right of 4. None of those make it true either. So let's take a look at the second example. It says D is less than or equal to 4. Notice that D comes first, or the variable comes first, so I know that the problem is written correctly. So what I want to do is let's go ahead and graph this. On the number line, let's start off with 0, and positive 4 is to the right of it. I'm going to place a solid circle at positive 4 because the inequality says less than or equal to. So anytime you have something that says equal to, you put a solid circle. And the arrow will be graphing all the solutions to the left, which means everything to the left of positive 4 is true. So let's pick a number that's on the left of the solution, like 0. 0's in the shaded region. 0 is less than 4. That's a true statement. Let's pick another number, like 4. 4 has a solid circle, so 4 is less than or equal to 4. That's also a true statement. So anything from 4 and to the left makes it true. Anything to the right of 4 does not make it true. So pause the video and complete these got it problems, and we'll discuss the answer in class tomorrow. Notice I've got two got it problems on this slide, got it problem C and got it problem D. Alright, so for example 3, it says graph the solution of the inequality. So notice for the first one on the left, it says 12 is greater than or equal to k. Notice the variable does not come first. So anytime that happens, you're going to have to make sure you flip the inequality around. So I want to make sure k comes first. And notice that the pointed side is facing towards k. So I want to make sure that the pointed side is continuing to face k. Notice the 12 has the open side next to it. So I'm going to place the open side right next to 12. So this is the same exact problem. Once we do this and k is first, here's k, it's first in the inequality, we can start to graph now. So I'm going to place a 0 on the number line. 12 will be on the right of 0. This is going to be a solid circle because it has an equal to sign in there. And every number to the left of 12 would make this true. So if you pick any number to the left of 12, including 12, it will make this true. Any number to the right of 12 does not make it true. Let's take a look at the problem on the right-hand side. It says 15 is less than W. Notice the variable does not come first, so we're going to have to rewrite it so that it comes first. So let's place W first, and the bigger side is open towards W. So let's make sure that the bigger side continues to face W. The pointed side is facing towards 15, so in this problem, the pointed side has to continue to face 15. Now that the variable comes first, we can graph the solution. So I'm going to place 0 on the number line. 15 goes to the right of 0. And this will be an open circle because there are no equal to signs here. And I'm going to shade everything to the right of 15. Anything to the right of 15 will make this solution true. Notice 15 does not make the solution true, because if I plug in 15 into the inequality, 15 is greater than 15, that's a false statement. So any number to the right of 15 will make it true. So pause the video, complete these got it problems, and we'll discuss this answer in class tomorrow. Notice there are two got it problems on the slide, got it problem E and got it problem F. So for example 4, it says of the numbers 6, 7, or 8, which is a solution to the inequality f plus 2 is less than 9. So let's go ahead and plug in each solution. Let's start with 6. If I say 6 plus 2 is less than 9, 6 plus 2 is 8, and 8 is less than 9, so that's a true statement. Let's try another one. 7 plus 2 is less than 9. If I add 7 plus 2, I get 9. 9 is less than 9, and that is a false statement. So far, the number 6 is the only number that makes this inequality true. Let's try one more. Let's try plugging 8. So 8 plus 2 is less than 9. 8 plus 2 is 10, and 10 is less than 9. That is also a false statement. So the only answer that makes this true out of 6, 7, and 8 is 6. So pause the video and complete this got it problem, and we'll discuss the answer in class tomorrow. So we've just completed the lesson. Go ahead and self-rate yourself and let us know how you feel. If there's any part of this lesson that you do not understand, please go back and watch the video again. Also come to class with some questions so we can discuss this in further detail.